This problem is to evaluate a limit of a function of two variables as one variable tends to infinity. Let the function h of x and y be defined as. The first term is y times cosine of the quantity x divided by y divided by 1 plus x squared times y. And from that, we subtract the second term, which is 1 plus y times the natural logarithm of the quantity 1 plus x over y, all divided by the inverse tangent of x. This function is defined for all x greater than 0 and y greater than 0. We now define another function, called k of x, as the limit of h of x and y as y approaches positive infinity. Our task is to find the value of k of x, expressed in terms of x. First step is to break up the limit. We split the limit into two parts. So k of x becomes the limit of the first term as y goes to infinity, minus the limit of the second term as y goes to infinity. Next step is to analyze the first term. Look at the first term. We have y times cosine of x over y, divided by 1 plus x squared times y. As y becomes very large, the quantity x over y becomes very small, approaching 0. So cosine of x over y gets very close to 1. That means the numerator becomes approximately y, and the denominator becomes approximately x squared times y. So the whole expression becomes y divided by x squared times y. The y's cancel out, and we are left with 1 over x squared. So the first term approaches 1 over x squared as y goes to infinity. Next step is to analyze the second term. Now, look at the second term. It is 1 plus y times the natural logarithm of 1 plus x over y, all divided by inverse tangent of x. Let's focus on the natural logarithm part. When x over y is very small, the natural logarithm of 1 plus x over y is approximately x over y minus 1/2 times x squared over y squared, and so on. Now, we'll multiply this by y. We get x minus x squared over 2y. As y grows very large, the second part vanishes, and we are left with just x. So now the full numerator becomes 1 plus x, and the denominator is inverse tangent of x. So the second term approaches the value of 1 plus x, divided by inverse tangent of x. Next step is to combine the results. Now we put it all together. The final answer is 1 over x squared minus 1 plus x over inverse tangent of x. Here's something useful to remember. When you're taking limits as y approaches infinity in multivariable expressions, look closely for small parts like x divided by y. They often let you use Taylor expansions or well-known approximations, like cosine of a small number being nearly 1, or logarithm of 1 plus a small number being close to just that small number. Split complex functions into separate parts, work through each term, and stay alert for simplifications. That's it for this question. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel. If you're looking for tutoring on final exam level questions, check out my YouTube channel at MathTutor8285. You'll find helpful explanations and strategies to ace your exams.